So good evening to all of you. So this is the transfer function of the loop. Just this is the same problem that we need to do. What you should do is, please show the question. So you need to find ultimate gain and frequency. Phase angle of open loop transfer function to minus pi. Find out what is omega c. This is what is. This is root 0.935. So did everybody get these answers? Since it is a repeated problem, so from yesterday, so we are not going to solve it. So did everybody get these answers? This is a practice problem for everybody. Try to solve it. Somebody is trying to unmute it. I don't know how you are doing it because I have muted everybody. See how what is the solution is phase angle of what is open loop transfer function Kc into 1 by 4s plus 1 into 2s plus 1 into s plus 1 is equal to minus pi. Phase angle of Kc. Are you able to unmute yourself? Oh. Can you unmute now? I have changed the settings. No. Okay. Okay. So what is phase angle of Kc? 0. What is phase angle of 4s plus 1? Tan inverse of minus 4 omega c. What is phase angle of 1 by 2s plus 1? Tan inverse of 2 omega c plus tan inverse of minus omega c, which is equal to minus pi. So tan inverse of minus 6 omega c by 1 minus 8 omega c square plus tan inverse of omega c minus omega c, which is equal to minus pi. Now, what is this value? Tan inverse of minus 6 omega c 1 minus 8 omega c square minus wc divided by 1 minus pi. So this tan inverse goes this side, it becomes 0. That means minus 6 omega c by is equal to 0. So omega c will cancel. So minus 6 minus 1 plus equal to 0. Now amplitude ratio of Kc into 1 by OTF is equal to 1. Amplitude, what is OTF is Kc into 1 by 4s plus 1 into 2s plus 1 into s plus 1 is equal to 1. So Kc divided by 1 plus 16 omega c square 1 plus 4 omega c square 1 plus is equal to 1. So let's substitute omega c, which is root 7 by 8. Then we will get 45 by 4. Which is 11.23. So this chapter 5 is completed. Just take 2 minutes time and read the entire chapter 5 once again. So we will start with chapter 2, which is how to find phase margin. Okay, we'll solve. See, phase margin is same. Equate the amplitude ratio to 1, find out the omega. At that omega, find out what is the phase angle. And phase angle plus 180 is the phase margin. Just take 2 minutes time and solve the. Just see all the frequency response. Second order systems. Chapter 2. These two are very small chapters. And advanced process control strategies. So what is the general transfer function of a first order system? Kp by tau s plus 1. Like this. What is the general transfer function of a second order system? Is Kp by tau square s square 2 zeta tau s plus 1. So this is the general transfer function of a second order system. Okay. Now, so what is tau time constant? What is the importance of time constant is if it is low, then the systems are fast. Systems are fast. If it is high, systems are slow. Then what is zeta? Damping factor. Here what we are not doing is, we are not doing any practical problem of second order systems. What we have done in the first chapter is we have taken liquid level tank and we have solved a practical problem. How do you derive the transfer function? So see here, then you will ask a question, what is the importance? What is the importance of zeta? What is the importance of zeta? So that is where, what is the characteristic equation here? Tau square s square 2 zeta tau s plus 1 is equal to 0. Can you find out what are the roots? What are the roots of characteristic equation? What are the roots of characteristic equation? So what are the roots of characteristic equation? So what are the roots? Minus b plus or minus root of b square minus 4ac square minus by 2 into tau square. 2, 4, 4, 2 will cancel. Tau square, tau will cancel. So what is left is minus zeta plus or minus root of zeta square minus 1 by tau. Now, if zeta is less than 1, then what is the nature of roots? Complex roots. Or let's say imaginary roots. When zeta is less than 1, imaginary roots. When zeta is greater than 1, what is the roots? Real and not equal. When zeta is equal to 1, real and equal. When zeta is equal to 0, the roots are on imaginary axis. On imaginary axis. Now let's see the responses. When zeta is less than 1, zeta is greater than 1, zeta is equal to 1, zeta is equal to 0. Zeta is less than 1. What is the nature of the roots is imaginary, real and unequal, real and equal. So here on imaginary axis. This is called as underdamped system. This is called as underdamped. This is called as overdamped. This is called as critical damped. This is undamped. So what is the nature of response? Here, response is oscillatory. Here it is non-oscillatory. Here also non-oscillatory. Here also it is oscillatory. So how does the response? How does the response is? This is how the response. So this is critical dynamics. This is class 5 minutes. 5 minutes. This is what is the response, or let's say nature of the response. Second and third one is both responses look similar, but when zeta increases, the systems will become slow. So that is why if you see, I'll show a lot of gap here in the second one. Third one, I have not shown the gap. Systems are little fast when zeta is low. So basically zeta increases, then slowness also increases. Systems will become slow. Now let's take, this is what is this thing. Now let's take what is step response. This all studies we have done in the first chapter also. We have taken a simple first order system Kp by tau s plus 1 and have seen, let's say, what is the step response. Now you don't need to remember this terms that I'm going to write, but Kp by tau square s square plus 2 zeta tau s plus 1. Suppose if you force the system by A by S, then we'll have three varieties. One is zeta less than 1, zeta is equal to 1, zeta is greater than 1. Kp into A 1 minus plus so these are one color brackets. These are same. Now when zeta is, let's say this is greater than 1, this is equal to 1. So no need to write also, don't write in your notes. After sine, root of 1 minus zeta square t by tau. So I'm just writing, but no need to write these equations also, because this is something which you will not, no need to remember also. Just this is what is zeta is greater than 1. So when zeta is equal to 1, So all these things will be multiplied by basically Kp into A. So here also Kp into A. So out of these ones, this is what is we will explore more. We'll explore. This is step response. So 100 amp response is important. So 100 amp response is important. Or is we'll explore more little bit on the 100 amp response. So if you see the responses, even if you see the responses here, when zeta is less than 1, it is oscillator because sign. When zeta is greater than 1, it is not oscillatory because cos h is not oscillatory. Cos is oscillatory. So when zeta is equal to 1, then it is this response, non-oscillatory. Then we have step versus time. So this is how the response. This is y of infinity. A, B, this is C. So this is how the response A, B, and C. So we will define some terms here. First one, overshoot. Overshoot is nothing but A by B. You will call it as A by B, which is overshoot is A by B. How do you get to this overshoot? So you take this equation. This is the equation that we are writing now. So you take this equation, and if you integrate this equation, you will get what is T max. If you put that T max, you will get what is A plus B. But you know what is B. So that B is nothing but final value. So that is how you can solve the overshoot. So what is that you will get is exponential of pi zeta by. You don't need to solve this one, but you know how to solve the solution. So you know the equation y as a function of t. Differentiate y as a function of t. You will get t max. You will put the t max. You will get y max. So that once you get y max is nothing but a plus b. What is b y of infinity? So what is y of infinity? Ultimate value. So that is how you get the overshoot. So next one is decay ratio. Decay ratio. So what do you call decay ratio is C by A is what you call as decay ratio, which is nothing but A by B whole square. What is exponential of minus 2 pi zeta by root of 1 minus omega zeta square? How do you solve this one? So if you, this equation, you know, which is nothing but, what is this equation is nothing but this equation, no? This is the equation. Then if you differentiate y as a function of time, you'll get first t max here, second t max. If you substitute second t max, you will get c plus b. So once you know c plus b, then if you put c plus b minus final value is c. So the next one is rise time. Rise time. So rise time is, now what is this rise time is this one. Response, write this one. Time required for the response to reach the ultimate value for the first time. This is what is called as t rise time. Time required for the response to reach ultimate value for the first time. So that is what is rise time. Second thing is response time. So here, time required for the response to reach plus or minus 5% of ultimate value. Let's say this is plus or minus 5%. Then this is what is what are the next values is frequency. Since it is a wave, you can define the frequency, which is omega equal to, because these are the terms which it signifies the response. The radiant frequency is 1 by root of 1 minus zeta square by tau. How do you translate this into cyclic frequency? To pi tau. So when zeta is equal to 0, you call them as natural terms. Only discussion of only we are talking about, no, frequency is omega by 2 pi. Time is 2 pi by omega. These are called as natural frequencies. Natural frequencies. Omega n is equal to 1 by tau. Fn is equal to 1 by 2 pi tau. So what is f by fn is root of 1 minus zeta square. Write this problem. A step change of magnitude, a step change of magnitude 3, a step change of magnitude 3 is introduced into the transfer function 10 by 2s square plus 0.3s plus 0.5. Calculate first max value of response, second one final value of response, third one overshoot, fourth one decay ratio, fifth one frequency, sixth one is natural frequency. What is the answer? So what is the max value of? So these are all, first thing is you have to translate this into a standard transfer function. What is the standard transfer function? 10 by 0.5, 2 by 0.5, s square, 0.3 by 0.5, s plus 1. And what is tau square? 4. What is tau 2? What is 2 zeta tau? 0.3 by 0.5. What is zeta? 0.15. Now if you substitute all this one, what is overshoot? What is the overshoot that you got? 0.621. What is decay ratio? Decay ratio 0.621 whole square. What is the response frequency? Root of 1 minus zeta square by tau. What is natural frequency? 1 by tau, the ratio. Now what is important is what is max value of I? So how do you find y of infinity? Y of infinity is nothing but what is x by y? 10 by 2s square plus 0.3s plus 0.5. What is x? 3 by s. What is y? 3 by s into 10 by 2s square plus 0.3s plus 0.5. Then what is y of infinity? S into y of s, limit s tends to 0. S and s will cancel. If you put this one, 3 into 10, 30 divided by 0.5, which is 60. So what is ultimate value? Y of infinity is 60. Now how do you find maximum value? How do you find the maximum value? From overshoot. What is overshoot? A by b is 0.621. So what is A? 0.621 into what is B is nothing but ultimate value 60. So what is maximum value? Y max is nothing but A plus B. Find out. So with this one we have solved one problem in, let's say, chapter 2. So let's solve some more problems tomorrow. So I'll take only 1 hour today. So chapter 2 I'll take, let's say, tomorrow and after tomorrow I'll complete chapter 2. Maybe then 2 days for chapter 5. Clear? So if we have any doubts, we'll go. Otherwise, we'll close the session here. How to do Y max? Y max is nothing but A plus B. So what is A by B? You know. What is A by B is overshoot, which is 0.621. Turn down ratios and all we'll discuss when we are talking about the control valves in the instrumentation part. Turn down ratio means how low you can go is basically turn down ratio. So then not sufficient. So I'll like now onwards and maybe I'll be. So I have only little syllabus left. Maybe 5 classes maximum is sufficient. Natural frequency is nothing but 1 by tau. No, there is nothing. 1 by tau. If you have any doubts, I can take the doubts. Yeah, we will cover in the last class the newly added topics. So I'll take the questions. Inert will increase catalyst activity. No. Please show zeta chart that you wrote. What is zeta chart? Pure capacity processes in the electrical, you will see, where the time constant is CR, capacity into resistance. No, it doesn't increase the reactor performance. The closed loop poles of a second order system could be. Poles means the transfer function becomes infinity, both real and positive. See, the question is wrong. The closed loop poles of a second order stable system. Stable, correct. Stable second order system. So that means both real and negative. Complex conjugate with positive real parts. One real positive one. See, this is stable roots means where it will be both real and positive will be right side. So it is unstable. Complex conjugate with positive real parts, unstable. Both real and negative, stable. One real positive, one real negative, unstable. So answer is both real and negative. So 1 by tau, just 1 by tau means frequency, root of 1 minus zeta square by tau. I am not. Whatever the answer that you will get. Okay, we'll meet tomorrow then for the rest of the sessions. 1.57, fine. Whatever the value that you get. Max value is 97.26. See how A by B is equal to 0.621. What is B is ultimate value, which is 60. Now that is why A equal to 0.621 into 60.